Before an agent swaps tokens, it may need permission to move them. That approval can be useful or dangerous. In this topic, we'll unpack swaps, allowances, slippage, routing, and the guardrails that make DeFi automation safer. We've built from agent fundamentals to blockchain access to wallet-aware automation. Now we'll connect those skills to DeFi execution, not just researching swaps, but performing them safely, with approvals, permissions, and risk controls in mind. For an AI agent, a token swap is more than a trade. It might convert a customer payment, rebalance a treasury, or carry out a strategy. That makes swaps powerful, but high impact. Prices can move, slippage can exceed limits, tokens can be fake, and approvals can expose funds. So an agent should never swap blindly. It needs checks for token identity, expected output, permissions, and policy approval before signing. With ERC20 tokens, your balance stays at your wallet address, and a contract cannot simply take it. First, you grant permission using approve, specifying the spender and the maximum amount. That creates an allowance. Later, the spender can call transferFrom, but only up to the remaining approved limit. This is why swaps, lending deposits, staking, and aggregators often require approval before the main transaction. To use tokens in a swap, the agent checks the existing allowance for that token and spender. If the allowance is too low, the wallet signs an approval transaction to the token contract, not the DEX. Once that transaction confirms, the agent can submit the swap. During execution, the DEX router calls transferFrom to pull the approved input tokens. The key risk is the allowance amount, because it controls future pull permission. Unlimited approvals are convenient, but they turn a one-time action into a standing permission. When approval is set to Wint256.max, the spender can move today's tokens and future balances of that token too. If that spender is malicious, hacked, or simply the wrong contract, no second approval is needed to drain funds. Because old approvals are easy to forget, agents should default to exact amounts and use unlimited approval only with explicit confirmation. Treat token approvals as a security policy, not a convenience feature. For one-time swaps, approve only the exact amount needed. Before sending any approval transaction, check whether the user already has enough allowance. After sensitive actions, consider resetting or revoking access so unused permissions do not linger. Most importantly, agents should only approve known, trusted spender contracts. Unknown routers should fail closed with human confirmation required for any exception. A swap transaction is a bundle of instructions, not just a token pair. The agent specifies what it will spend, what it expects to receive, and whether the fixed amount is input or output. The route may pass through multiple pools, so price can move before execution. Slippage tolerance sets the maximum acceptable change. Finally, the recipient address must be checked carefully, because it receives the output tokens. Swap routes move through one or more liquidity pools. A direct swap uses a single pool, which is simple but only effective if that pool is deep enough. A multi-hop route may pass through WET or another common token to find better liquidity. The main risk is price impact. A large trade can move the pool price and reduce output. Agents should compare reputable DEXs and aggregators before signing. Slippage tolerance turns a quote into a safety boundary. If the quote says 100 input should return 50 tokens, a 10% tolerance sets amount out min at 45. The swap may execute at 50, 48, or 45, but not at 44. That protects the user from sudden price movement or manipulation. Set it too tight, and normal volatility causes failures. Set it too loose, and the agent may accept a bad trade. No swap should be valid forever. Deadlines cap the window in which a transaction can execute, so an old quote cannot suddenly fill after prices move. Short deadlines are safer, but they can fail during congestion. The recipient is equally critical. Output tokens should go only to the user wallet, an approved vault, or a verified contract. Agents should reject any swap with a mismatched recipient, chain ID, router, or expired quote. For swap agents, guardrails turn good intentions into enforceable transaction policy. Before signing, the agent verifies the token contract, router, recipient, amount, and user authority. Slippage should be capped dynamically, based on volatility, trade size, and user preference. Amounts need limits per transaction, per day, and per strategy. Anything suspicious is rejected. Anything high value, unusual, or first time should pause for human confirmation. Token validation has to happen at the contract level. A symbol like USDC is only a label, and attackers can reuse it on fake contracts. The agent should compare the contract address against trusted lists or user allow lists, confirm the chain ID, then inspect decimals, metadata, liquidity, and transfer behavior. If transfers are blocked, fees are abnormal, or liquidity is thin, the safe default is rejection unless the user has explicitly approved that exact asset. Safe agent swaps should behave like a controlled pipeline, not a free-form action. Start by gathering competing quotes from trusted sources and comparing route, output, gas, and price impact. Then validate every parameter: tokens, router, slippage, deadline, recipient, and limits. Check allowance separately with exact approvals preferred. Only after confirmation should the transaction be submitted. Finally, verify the received amount, monitor status, and log decisions for audit. Token swaps give agents real DeFi power, but every signature matters. Validate approvals, routes, slippage, deadlines, and recipients before execution. Use limits, trusted tokens, verified routers, exact approvals, and human confirmation when risk increases. Safe execution is the foundation for governance, NFT, community, and creator agents.